Okay, so this is called Ferrari car engine. Okay, let's say it's pointing at this engine object here, and just to get some space here, let's put it at the very top. And then on my second instruction, I'm saying BMW car engine equals new engine. So car engine. And now I'm saying entirely a new engine. I'm creating a brand new second engine object on the heap here. Okay, so let's do this. Let's just make this smaller here. Okay, as you guys can see, I do not have the best drawing skills here, so it's going to get a little bit messy. And okay, so let's just ignore this picture at the bottom half. Okay, first let's try to get this cleared up. So I'm creating a new BMW car object. Alright, I need that. Okay, I did not get my text copied, so maybe I should have grouped everything. Okay, there you go. So far so good. I've got two engine objects on my heap. Okay. Alright, let's get rid of this. Let's get rid of that arrow. Okay, let's not worry about the arrows just here. Okay, and now let's see what's happening. Code. Now I'm saying car Ferrari equals to new car, but now instead of passing a generic car engine, I'm going to say, well, a Ferrari has a Ferrari engine, so I'm going to say this has a Ferrari car engine. Okay, and for BMW, well, this does not take in a generic car engine anymore. It takes in a BMW car engine. Alright, let's go back to your code here. What's happening? So I'm creating a reference called Ferrari on my stack. Is pointing at a car object. The car object has within itself these instance members here. But what is the car engine instance member containing as a value? As a value, it contains the same memory. Well, as a value, it contains the same value what the local reference Ferrari car engine contains. So it's basically pointing at it's pointing at this car, at that engine object. Okay, this is what the car engine of my Ferrari is pointing at. And likewise, when I create a new BMW car, okay, when I create a brand new BMW car object right there, which is this piece over here, within that car object, the instance member car engine is pointing at the value of the local reference variable BMW car engine. Because what I'm doing here is I'm taking whatever the values inside here, passing that as a parameter into the constructor. Okay, and what does this constructor do? This constructor basically takes that E, which is the local variable coming into the constructor, and assigns it to the instance member car engine. Okay, so from a picture point of view, this is going to be something like that one. Okay, this is how my picture has changed here. So let's do a quick recap here. On my stack, these are my local variables. Okay, I've got a Ferrari car engine, BMW car engine, Ferrari, and BMW. On my heap, I've just got the objects that are created on the heap. These are my different objects. But the instance variables also live on the heap. These are my instance variables right here. These guys are my instance variables, and they also happen to live on the heap, right? Compare and contrast my instance variables with my local variables. Local variables always get created on the stack right there. Okay, and these instance variables get created on the heap. Okay, so let's do this now. Let's just go back and let's go back to test.java. Okay, and let's just put some few scenarios. Let's say at this point, if I say Ferrari car engine equals to null. And what does that do? Well, if I say Ferrari car engine equals to null, that basically sets the value into my local variable Ferrari car engine to null. So what was it containing previously? Well, previously it was containing the memory address of this engine on the heap. Now when I set it to null, I'm basically getting rid of this. It basically becomes something like this. Ferrari car engine is basically pointing at null, meaning it is not pointing at this object anymore. So my question here is, will this object get garbage collected just by setting Ferrari car engine to null here? Let's just look at just after this instruction. When this instruction gets executed, is that sufficient for the garbage collector? So let's just put a comment here. If Ferrari car engine is set to null, will the garbage collector remove the engine object? So what's the criteria? How does the garbage collector work? The way the garbage collector works is that it must have 0 or no references pointing at the object in order for it to be taken away from the heap. Look at this object over here. After removing that reference, after removing the reference of Ferrari car engine, does this object still have any other reference pointing at it? And I can see it does. The other reference is coming from right here. It's coming from car engine, meaning that this object will not get removed from the heap just by saying Ferrari car engine equals to null. Okay, so keep that in mind. And likewise, if I were to do something like BMW car engine equals to null here, same idea. That means that the BMW car engine has been set to null. This gets removed. Will this object get taken off from the heap? Nope, because I still have one of these references pointing at it. Okay, so let's just move on with the example and let's see what will happen here if I say Ferrari equals to null. If I say Ferrari equals to null, okay, so when Ferrari is set to null, what will happen is this gets deleted, this gets taken off. Now the question is this car object, is there any other reference pointing at this car object? I can see that there are no references pointing at this car object, meaning, is there any way to reach this car object? Well, there's no way to reach that car object because I have no references containing the memory address of where this car object happens to be on the heap, which means the garbage collector kicks in. The garbage collector will remove this object, it will remove it entirely. So that object gets removed. And so this object got removed, it got removed. Okay, and because that object got removed, meaning that this reference also got removed because this was from the car object, right? This got removed as well. And that reference got removed. If you ask the same question again, is this engine object being pointed by any other reference? Well, no, this engine object is no longer being pointed by any other reference, meaning that the garbage collector will kick in again and take this object also away from the heap. This object also gets removed from the heap. Okay, so I hope this was useful. We're going to look at memory, the Java memory model a little bit more in detail in week 5, and we'll look at the stack frames, how the stack frame gets allocated on the stack, and how the static objects get allocated on the heap. But the most important takeaway point, at least from today's screencast, is I just wanted to connect some of the material that we learned last lecture and put it together in a simple program, and again understand how different regions in the memory via the stack and the heap get allocated.